So, to piggyback on what I was telling you yesterday, that you've got stages of coal, you've got the pre-stage, then you've got lignite, bituminous, and anthracite. And what I want you to know, besides what I told you yesterday, that as time progressed, you got anthracite, and anthracite was dug deeper, and it was subjected to more heat from Earth. So since it's deeper and deeper, and more time has passed, the highest heat producer is going to be what?
The last one.
Which is? Anthracite. Good. And that's the one we would most want, because the more heat you start off with, the more electricity you're going to get, because coal's main function is to produce electricity. But the one we most have is bituminous. So our ideal situation would be to have a lot of anthracite because it's the highest heat producer, but bituminous is equally good, and it's the one. Now, there's a lot of peat in the world. But peat is not used to produce electricity because it doesn't produce enough heat, because that's a pre-stage of coal. All right, so how do we get it? We mine for it, and the type of mining we use is surface mining. Whenever you see that word overburden, that's like removing a whole layer of land to get to where we want to get to mine. So that's what's considered surface mining. So surface mining is like on the top layer of land, let's say, if you're still digging, and they use a lot of trucks because what you dig, like all that extra overburden has to be shipped off. Most of the times they use it to regenerate the land afterwards, so whatever they took off, they put back, but they form these little like roads, so while they're mining, they can take all of the stuff they mine out of the mining area. So for each, we already did major uses, but I'm going to refresh them, and then I'm going to talk about advantages and disadvantages. So that's really the whole concept of this unit. So we know electricity production is one. What's number two? I told you this yesterday.
For transportation.
No, for coal. You going to put coal in your car?
No.
What's the second one? The one that every energy uses.
Industrial.
Industry. Good. So the question is, what do we use coal for? We use it for electricity, that's its main use, and the second is industry. That's all you have to know on this test for that. Now here are some examples of how we use it in the industry, and you don't have to know that. But I don't know if you know, they use coal to make steel, they use coal to make plastic, tar, all these things that are like really important in the industrial world. All right, so the biggest part of this unit is how is coal transformed to electricity. Once you learn this, every type of energy that produces electricity does it in a very similar fashion, except two. So if you learn this concept, you're going to learn all of them, okay, easily. That's why I'm going to have you make the animations. So who could tell me what's the first thing we need in order to transform coal into electricity? Coal, obviously. We're going to take the coal, and it's going to go through a whole processing, okay? That's before you even take it to FPL. It goes through a whole refining, and they do that to remove excessive amounts of sulfur, which are found in coal, and impurities, because they're going to get burned. So you're going to burn it. That's the first step. You burn coal. And your animation is going to start with coal being burned. You don't have to talk about coal being refined. After you burn it, you're going to add water. Anybody know why? Based on yesterday's research?
To solidify.
Nope.
They use the steam.
Correct. He wasn't even here.
Steam is what powers it.
Correct. The water's added to produce steam. The steam spins the turbine. So you have coal burning. Has a high heat. If it's anthracite, it has high heat. If it's bituminous. We add water through the system. The water turns into steam. Steam pushes a turbine, and if you look at the picture right there where the turbine is, it's spinning. Steam turbine.
Why do we need steam to spin the turbine?
Because everything is energy. Energy can't be created or destroyed. So you need energy to make energy. Our goal is electricity. In order to send an electric current, we need some kind of motion. So the steam spins a turbine that starts the mechanical energy, which is attached to an electric generator, and the turbine gets the electric currents flowing in the generator.
Wouldn't it be like better if you like say if you had use of the technology like electricity before, you had like a big battery or something, you connected that to the turbine and then the electricity spins the turbine.
What's powering the battery?
It doesn't matter because I was going to say the turbine could give that battery power and the power to the electricity.
But you need an initial source of energy. What powered the battery?
Oh.
You get it?
Yeah.
So there are better ways, and you're right, like using solar power maybe to get a battery in the battery to spin the turbine. So in the end, they're thinking of all these things. But the steam engine, remember, that's Industrial Revolution. This is what it is. How do I spin a turbine to get the current going? And this is how they're spinning the turbine. Genius idea. And then that electric current obviously is going to be sent to your home. And in the process of the electric current being sent to your home, water is either cooled and reused or it's dumped into the ocean. Remember, that's where the thermal pollution kicks in. I'm going to pause. So where you see the coal, this is a river and not an ocean. Coal is brought in after it's been refined. That would be the refining plant over there to the side. And then it's added to a boiler. Water comes from the river into the boiler, and it's cold water, room temperature water, and it gets heated. And then it's produces steam. Steam spins the turbine. The turbine is attached to a generator. Generator sends electric current to the power plants. Okay? So why is this good and why is this bad? Well, obviously we need electricity, so that's a great thing. But in terms of good and bad, we're going to compare it to other fossil fuels. It's not, is this great? It's how is this great compared to other energy sources that produce electricity? Number one, it's the cheapest of all the fossil fuels. Obviously, the United States owns it. That's actually number two. We have it, it's the most abundant in the world, and we, as a country, have the most of it. So coal reserves in the US are the highest. And there's a picture of the map of what kind of coal we have and where. So the bottom line is we own the coal, so the prices in the US should be relatively cheaper. We have enough coal to last 236 years, approximately. Those figures fluctuate. It is the highest heat producer of all the fossil fuels. So if you compare coal, natural gas, and petroleum, coal will produce more heat, which means we're going to get more steam and we're going to get a bigger current of electricity. So that's also good. So disadvantages, again, in comparison to other fossil fuels, which you haven't even learned about, or other alternative energies. It's super dirty. So you compare coal and think about it. Something solid is going to produce more pollution than something in a liquid state or a gas state. So coal is the dirtiest fossil fuel. It produces more sulfur and more carbon dioxide than any of the other fossil fuels. What does carbon dioxide lead to? Global warming. What does sulfur lead to? Acid rain. Okay? So you're going to have to worry about these problems, the greenhouse effect and acid rain. And that's actually, so it leads to the greenhouse effect. And obviously a disadvantage is going to be mining and all the effects that come from mining. Mining disturbs the land, uproots people, leaves toxins behind. So all of these issues arise from trying to obtain the coal.